Alright, good afternoon Year 12s. Today we're going to make a video about yield, which is a description of how much is actually produced in a reaction compared to how much of a product should be produced in a reaction. Okay, so you might have heard of yield before in the context of when you're producing something and you don't produce all that you're supposed to, then the yield is quite high or quite low, things like that. Alright, so in theory, if I have 10 slices of bread and 5 slices of ham, I should be able to make 5 sandwiches. However, in the process, I might get hungry, and then I might eat one, and then I only produce 4 sandwiches. So therefore, the yield is only 80%, because I produced only 4 actual sandwiches, instead of the 5 theoretical sandwiches I'm supposed to make. So inevitably, in a reaction, some of the molecules, some of the particles escape or go down side reactions, which they're not supposed to, and that's why you might have less than what you're supposed to create. So the equation for yield is this. Yield is the number of moles actually made over the number of moles theoretically supposed to be made times 100. Okay? So, now, something that we are going to need to rearrange this equation lots, but something that you need to remember is that you must use the number of moles to calculate the yield. Now, technically, you could do yield in terms of anything that's theoretical and actual, like mass or concentration or pressure or something like that, but you need to calculate it using number of moles because you will have marks taken off you if you do not calculate it using the number of moles. Okay? Mathematically, you can use other things, but chemically, you must use number of moles when you're talking about yield. So you need to be able to determine the yield of a process given how much you started off with and how much you produced. Apply yield to solve how much is produced, and apply yield to solve how much is needed, which will require us to rearrange this equation, the yield equation, and we'll get on to examples of that later on. So here is the questions for this particular topic. We're going to go through a couple of them just to show you how to do it, and then you're going to try the rest of them on your own. Okay, so the first question. A manufacturer of soap uses fat/oil with carbon chains of 18 carbons in length with a molar mass of 891.45 grams per mole. To a 2.43 kilogram sample of this fat oil with a 94% purity, he reacts it with excess sodium hydroxide to form soap and glycerol. Once all of the glycerol and water have been removed, he is able to collect 2.07 kilograms of soap with a molar mass of 22.99 for the sodium and 283.46 for the soap particle, grams per mole. Determine the yield of this process, and here is an equation for that. All right, so I've written down all of that information that's required on this piece of paper here. All right, so you've got the molar mass of the fat, you've got the mass of the fat, including its purity, you've got the mass of the soap, you've got the mass of the molar mass of the soap. Okay, and here's the equation here. So you're supposed to be able to produce a certain amount of soap, however, you only produced this 2.07 kilograms of soap. We're going to find out what we were supposed to produce, and then we'll be able to work out the yield. So first of all, we need to work out how much we were supposed to produce, which means that we need to work from the mass of the fat that we were provided with, the fat here. So the mass of the fat will be equal to, now it's not 2.43 kilograms because we recognize it's 94% pure, so we're going to have to work out what part of this sample is actually fat. So 2.43 times 0.94, right? Which will equal to 2.28 kilograms of fat. Okay? So, which is equal to 2284.2 grams. Okay? We just convert that into grams because the next thing we need to do is work out the number of moles of this fat. Okay? If we've been given the mass and the molar mass, which is 891.45, we should be able to solve for the number of moles of the fat, which will be equal to 2.56 mole. Right? So now we can work out the number of moles of soap. Now we have to annotate this here, that we are theoretically supposed to be able to produce. Okay? So the number of moles that we are theoretically supposed to be able to produce is the number of moles of fat times the molar ratio, which is 3/1, which then happens to make it 7.69 moles. Right? So that's how much moles we're supposed to theoretically be able to produce. Now we have to work out how much moles of soap we actually produced. So the number of moles of soap actual will be equal to the 2,070 grams of soap that we actually produced divided by the molar mass of the soap, which happens to be 306.45, okay? Because remember, this is the sodium plus the soap particle, which then happens to be 6.75 moles. So now we need to do the equation. The yield will be equal to the number of moles of soap actual over the number of moles of soap theoretical times 100. Okay, so it's 6.75 over 7.69, and I hope that you are using your calculators to save your numbers. Right, times that by 100, and that will be 87.9%. All right, so that would be the yield of this particular process. That's how much soap that is actually made compared to how much was being able to theoretically be able to make. All right, so that's the first question there. Let's have a look at the next question. Right, so we're going to do question number 2. So let's have a look at that. A reaction vessel is fed with excess hydrogen gas and 168.6 litres of nitrogen gas at 25 degrees Celsius and 101.3 kilopascals. This is allowed to reach equilibrium, and the ammonia that is produced is found to weigh 68.07 grams. Determine the yield of this process. All right, so again, I've written down all the important information onto this sheet of paper already, so let's have a think. We need to work out the yield, so we need to work out the amount that was theoretically supposed to be able to made, the amount that was actually made, and then we have be able to work out the yield. All right, and when I say the amount, I mean the number of moles. So let's first of all work out the number of moles of N2, which will help us get to the theoretical number of moles of ammonia that was supposed to be able to be produced. And the number of moles of N2 is going to be equal to, what equation should we use? We've got P, V, and T. We're going to use the PV is equal to nRT equation. Pressure is 101.3, volume 168.6 over R 8.314 times T. Now T has to be in Kelvin, 298.15. Okay, 25 degrees Celsius plus 273.15, which will get you the degrees in Kelvin. Okay, so what's that equal to? That's equal to then, the number of moles of N2 is 6.89 moles. Okay, so we should be able to work out the number of moles of NH3 that we are theoretically supposed to be able to produce, which will be the number of moles of N2 times 2 over 1, which will be 13.78 moles. So now we have the number of moles of NH3 that we are theoretically supposed to be able to make. Now let's work out from the mass of the ammonium that we actually did make, the number of moles of ammonia actual, okay, which will be 68.07 over the molar mass of ammonia, which happens to be 17.034, and that will give us 3.996 moles. Okay, again, yield is equal to number of moles of NH3 actual over the number of moles of NH3 theoretical, right, times 100, and that will get us, what, 29%. Not a lot. That's fine. Right. So, let's move on to our next question. Let's have a look. We're going to be doing question number... So the next couple of questions are asking you to find out the yield of something. Now let's go to question number 5, where it's changing the type of question, and we have to apply the yield. So nitric acid is produced by the Ostwald process, which the last step is nitrogen dioxide and water combined into nitric acid and nitrogen monoxide. If the process is a 97% yield, determine the mass of nitric acid produced in the processing of 94 litres of nitrogen dioxide at STP in excess water. Okay, so from this text we can see that nitrogen dioxide and water are combined into nitric acid and nitrogen monoxide. So I've written down the important information already. The yield is 97%, the volume of NO2 is 94 litres at STP. So we now have to work out how much HNO3 is produced during this process, okay? Because not all of it's going to be produced, only 97% of it is going to be produced, right? So let's work this out. First of all, let's start off with what we know. We've got the volume of NO2, and we know that it's 94 liters at SDP, so therefore we can work out the number of moles of NO2, which will be equal to 94 divided by 22.71, because of the SDP, which happens to be 4.14 moles. Now we've got the number of moles of that, we can work out the number of moles of HNO3 that was supposed to be made. Okay, so we can work out the number of moles of HNO3 theoretical, which would be equal to, I balanced the equation already, but it would be equal to the number of moles of NO2 times, what's that, 2 on 3, which would be equal to 2.759 moles. Once I've got the number of moles of HNO3 theoretical, I need to work out the number of moles of HNO3 actual, which means I need to rearrange the yield equation. So the yield equation rearranged, remember, yield is equal to actual over theoretical times 100. So now I want to find the actual. So I'm going to take the theoretical, times it by the yield, and then divide it by 100. So the number of moles of HNO3 theoretical, times it by the yield, over 100. Okay, so that's 2.759 times the yield, which is 97, over 100, which just so happens to be 2.68 mole. Am I done? Nope. I need to work out the mass of this HNO3 because that was what the question asked. So the mass of HNO3 will be equal to the number of moles times the molar mass, which will be equal to 2.68 times the molar mass of that, which happens to be, what? 3 times 16 plus 14.01 plus 1.008, 63.018 times that would be 168.68. Okay, make sure you're saving your numbers in your calculators, otherwise you're not going to get an exact number like I did. All right, so you have to be able to rearrange this equation. This is just one example of it, where we're working out the actual. In the next example, we're going to work out a theoretical. So questions between 5 and 9, or just 5 to 8, are using the yield to work out how much is produced. Now the last 3 questions is going to be asking us to work out how much do we need to start with given the yield. So let's look at question number 9. Glucose is a sugar which can be converted into carbon dioxide and ethanol. If the process has a yield of 82%, how much glucose would be needed to produce 20 liters of ethanol with a density of 0.789 grams per mil? Okay, so again, I've written down all the important information. I have not balanced this equation yet, so let's have a think. I need to balance out the hydrogens. Let's do that. I need 2 of those. Why did I choose to balance out the hydrogens first? Because the carbons and the oxygens are in 2 of them, so let's not balance that out until the very last. Right, so hydrogens in this one, that's 12. Right, therefore I need to have, I've got 4 carbons here, I need another 2 carbons here, and that will also make 4 oxygens there, 2 oxygens there, 6 oxygens there. That's balanced. All right, so first of all, we need to work out the number of moles of ethanol over here that we actually have. All right, that's the number of moles of ethanol that we actually have, because we're going to need to work out how much is theoretically we needed to have, and then work out how much we needed to make from it. So we're going to use the density equation, where mass is equal to density times volume. And what have I written wrong there? I haven't written what I'm solving. M of ethanol, which will be equal to D times V. Right, density 0.789 times 20 liters. I've got to make sure that my units for the density, this is in liters, this is in mils, they have to be the same, so I'm going to convert the volume into mils. which is 20,000, which gets me to what value? That gets me to 15780 grams. Right, so that's quite a bit of ethanol that's produced, but that's fine. So let's work out the number of moles of ethanol actually produced. Right, this would be 15780 over 46.068, which happens to be 342.5 moles, which is a lot. But let's go on. So now I need to work out how many moles of ethanol I needed to theoretically make to make the actual. So the theoretical, again I have to rearrange this equation, yield is equal to actual over theoretical times 100. So now I want theoretical. So theoretical will be equal to the number of moles of C2H6O actual over the yield times it by 100. Okay, so 342.5 over, what is the yield? 82% times 100, which happens to be 417.73 moles. Okay, quick hint on this one. You need to be able to see that, okay, in this example, the theoretical is 400, the actual is 300. The theoretical should always be larger than the actual, okay? So the theoretical should always be larger than the actual. This is the last example. The theoretical should always be larger than the actual, right? So now that I have that one there, 417.73 moles, now I need to work out the number of moles of sugar, 06, from the number of moles of ethanol, theoretical, which will be half of it, okay, which happens to be 208.86 mole. And then I'm going to be able to work out the mass of that sugar, which will be equal to, what's that? 208.86 times a lot. What's the molar mass of sugar? 6 times 12.01 plus 12 times 1.008 plus 6 times 16, 180.156, which happens to be then 37628 grams, which is equal to 37.6 kilograms. Right. And so that is how you work out the amount needed from a certain product. Okay, just keep in mind these two here. All right. No, that's not the right one. This one here. Okay, so this question here, question number 5, asked you to work out how much is actually produced from what is supposed to be produced. Okay, so therefore you do yield over 100. Okay, this question here is asking you to work out how much you needed to produce a certain amount. That's why you used 100 over yield. 100 over yield. All right, so this one here, yield over 100. This one here, 100 over yield, depending on what you're asked to work out. Product, yield over 100. Reactant, 100 over yield. Okay, and that's all there is about yield.